Maybe you know, science meets the questions you never thought to ask. Right now, 24 billion kilometers from where you're sitting, a spacecraft the size of a small car is moving through total darkness at 60,000 kilometers per hour. It has been traveling for 47 years. It has crossed our entire solar system. It has now left the boundary that the sun's wind defines as home. And every single day, it sends back a faint whisper of data, so we could take specially built antennas to detect. Its name is Voyager 1, and the story of this single fragile machine is one of the strangest things humanity has ever done. Voyager 1 launched on September 5, 1977, from Cape Canaveral in Florida. It was built to do a 5-year mission. Just 5. The plan was to fly past Jupiter, then past Saturn, take photographs, beam them back, and that would be it. The engineers who built it expected the spacecraft to stop working sometime in the early 1980s. They were wrong by 40 years. Voyager 1 is still operating today. The original engineers who designed its computers are mostly retired or dead. The team that talks to Voyager today uses original 1974-era programming language to send commands to a machine drifting through interstellar space. And here's the strange part. Voyager 1 has only 69 kilobytes of memory. That is 1/10,000th the memory of a modern smartphone. With that tiny brain, it has photographed Jupiter's moons, found active volcanoes on Io, measured the rings of Saturn, and is currently the most distant man-made object ever created. On board Voyager 1 is one of the most poetic objects humans have ever sent into space. It is called the Golden Record. The project was led by an astronomer named Carl Sagan in 1977. Sagan and his team had only 6 weeks to decide what to put on it. 6 weeks to compress all of human civilization onto a single 12-inch disc made of gold-plated copper. They included greetings recorded in 55 languages. The first words of the record, in ancient Akkadian, are roughly translated as "May all be well." There are sounds from Earth, a heartbeat, a mother kissing her child, the crash of waves, whales calling underwater, thunder. There are images encoded onto the disc in analog form, from a fetus to a footprint on the moon. And there is music, Beethoven, Bach, Chuck Berry's Johnny B. Good, a Bulgarian folk song. The record is wrapped in a protective case with a diagram showing how to play it, drawn for an alien who has never seen a record player. Now picture this. Voyager 1 travels at about 17 kilometers per second. To put that in scale, that is 10 times faster than a bullet. But space is so empty that even at that speed, Voyager will not approach another star for another 40,000 years. 40,000. The closest star Voyager will pass is called Gliese 445 in the constellation Camelopardalis. By the time Voyager gets near it, every human alive today, every civilization currently on Earth, every language we speak right now will be gone or unrecognizable. The Golden Record is a message in a bottle thrown into an ocean so vast that the bottle takes longer to find shore than civilizations take to rise and fall. And yet, that is the entire point. We launched it knowing this. The record was not made to be heard soon. It was made to last. Here is the part that will mess with your sense of time. In 1990, Voyager 1 was passing the orbit of Pluto, about 6 billion kilometers from Earth. Carl Sagan, who was on the mission team, asked NASA to do something unusual. He asked them to swing Voyager's camera around, backwards, toward Earth. NASA argued the camera was useless this far out, but Sagan kept pushing. Eventually, they agreed. Voyager turned its camera and took one final picture of Earth. In that photograph, our entire planet, every human who has ever lived, every war ever fought, every love song ever written, every ocean and continent, takes up exactly 0.12 pixels. A single dot, less than a pixel. Sagan called it the pale blue dot. He said, "Look again at that dot. That is here. That is home. That is us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. From space, we are a speck of cosmic dust suspended in a sunbeam." Voyager 1's signal is unbelievably weak. The transmitter on board has the power of about 22 watts. That is the power of a refrigerator light bulb. After traveling 24 billion kilometers, the signal arrives at Earth so faint that it is roughly 10 to the minus 18th watts. That is less energy than a snowflake landing on your shoulder. NASA picks it up using massive 70-meter-wide dish antennas at the Deep Space Network in Goldstone, Madrid, and Canberra. The signal takes 22 and a half hours one way. So when NASA sends Voyager a command, the round trip is 45 hours. That is 2 days. 2 days for one conversation. Voyager's data rate is now under 160 bits per second. A single low-resolution photograph would take days to transmit. We are not chatting with Voyager. We are listening to a whisper from another era. Voyager 1 is dying. Slowly. It is powered by 3 radioisotope thermoelectric generators, basically chunks of plutonium-238 that produce heat as they decay. That heat gets converted into electricity. The plutonium is decaying steadily. Every year, Voyager loses about 4 watts of power. NASA engineers have been turning off non-essential instruments one by one to keep the spacecraft alive. The cameras were turned off in 1990. The plasma science instrument died in 2024. The cosmic ray detector is one of the last things still running. Engineers expect the last instrument to go dark sometime around 2025 or 2026. After that, Voyager will stop transmitting. It will continue moving outward, forever, carrying the golden record, carrying Beethoven, carrying the heartbeat of a Russian astronomer's wife, carrying every greeting in 55 languages, drifting toward Gliese 445 at 60,000 kilometers per hour. And it will not stop until something physical makes it stop, which may never happen. And here is the deepest twist. Once Voyager goes silent, it does not stop being a message. It becomes one. For the next billions of years, it will travel through interstellar space, mostly empty. Almost nothing in space ever decays. There is no oxygen to corrode metal, no water to erode surfaces, no bacteria to dissolve plastic. The temperature is hundreds of degrees below freezing. Astronomers calculate that Voyager will probably outlast the Earth itself. The Sun will become a red giant in roughly 5 billion years and consume our planet. By then, Voyager will be deeper in interstellar space, still drifting, still carrying the golden record. There is a real possibility that long after every human is dead, every continent gone, every trace of us erased from this solar system, the most enduring object that humanity will ever create is a single fragile spacecraft holding a recording of a Bulgarian folk song and the laughter of a child. So when you look up at the night sky tonight, in the rough direction of the constellation Ophiuchus, somewhere out there beyond the planets, beyond the heliosphere, in space so dark and empty, it is impossible to truly imagine, a small spacecraft built by a generation that is mostly gone is still moving, still carrying the song of every culture on Earth, still whispering back at us. For now, the plutonium fades, the signal weakens, but the record on its side does not need power. The record will play in silence, alone, for the next 1,000 million years. Voyager 1 is humanity's loneliest object, and our most permanent goodbye. Voyager 1 will outlive Earth, our sun, and probably everything we have ever built. But Voyager has a twin sister, Voyager 2, that took an entirely different path through space. And Voyager 2 visited 2 planets that no spacecraft has visited before or since. Subscribe, and we will follow Voyager 2's stranger journey to the edge of the solar system. Thanks for watching. If this sparked a question, drop in the comments. It might be your next video. We'll see you next time.